Hi guys, so today we're going to be doing conditional statements. Before we get started with our examples, I just wanted to cover all the parts of the book about definitions and everything. Okay, so we're going to start off here with if-then statements. So a conditional statement is just a statement that can be written in the if-then form. Okay, this is an example here. If you buy a car, then you get $1,500 cash back. Okay? An if-then statement is written if blah, 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 then blah, 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 okay? The phrase immediate following the word if is known as the hypothesis, okay? And then the phrase following the word then is known as the conclusion, okay? You will often see it as a symbol as this, P, arrow, Q. And it's read as if P then Q or P implies Q, okay? And then again, before we start with our example, I wanted to do some other definitions here, okay? Later on, we're going to be talking about related conditionals, and that is here, okay? We just talked about the conditional, that's the if-then statement, okay? The converse is if we flip it, okay? We exchange where they're, which one's the hypothesis and which one's the conclusion, right? So if the conditional was, if two angles have the same measure, then they are congruent. The converse would flip it, and note now instead of saying then they are congruent, it's flipped. It's if two angles are congruent, then they have the same measure, right? So conditional is P then Q. The converse is Q then P, right? We get the inverse by negating both of them, okay? Both the hypothesis and the conclusion of the conditional, right? So then it changes to if not P, then not Q, okay? And then the contrapositive negates both of them and flips their order. It would be if not Q, then not P, okay? And then at the bottom, you'll see the truth tables for it of how we know when one thing or another is true. Okay, so let's get started with example one. Okay, example one just wants us to identify the hypothesis and the conclusion. Okay, so remember the hypothesis is the part after the if, the conclusion is after the then usually. Okay, so here, if points A, B, and C lie on line L, then they are collinear. So this part here is the hypothesis. Okay, it's followed after the if points A, B, and C lie on line L. So hypothesis is point A, B, and C lie on line L. The conclusion is that they are collinear. This is the conclusion. Okay. So B, it says the Tigers will play in the tournament if they win their next game. Okay. So this time the hypothesis is towards the end. However, the hypothesis follows the if. Okay. So the hypothesis is if they win their next game, okay, what would be the result or the conclusion? The conclusion is then the Tigers will play in the tournament. Okay. So you can't go just by the order of it. It's what comes first and what comes after, right? It's if is the hypothesis, and then what results is the conclusion. Okay, so you're going to try 1A and 1B, identify the hypothesis and the conclusion. Okay, this is what you should have gotten. 1A, the hypothesis is a polygon has 6 sides. The conclusion is that it is a hexagon. Okay. For 1B, the hypothesis is the first one is sold out, or the first performance is sold out. The conclusion is that another performance will be scheduled. Okay. So next is example 2. We're going to write the condition in if-then form. We're going to identify the hypothesis and conclusion of each statement, and then write each equation in if-then form. Okay. So let's take a look here. An angle with measure greater than 90 degrees is an obtuse angle. Okay, so this part is the hypothesis. that an angle with a measure greater than 90. The conclusion is that it's an obtuse angle. So then writing my statement, if an angle with a measure greater than 9, if an angle has a measure greater than 90 degrees, has a measure greater than 90, then it is an obtuse angle. Okay, there you go. Okay, next part is B. The length of the course for an inline skating marathon is 26.2 miles. Okay, so this part is going to be my hypothesis. Okay. And then this part here would be part of my conclusion. Yep. And now I'm going to write my sentence. If a course is for an inline skating marathon, then its length is 26.2 miles. There you go. Okay. You're going to work on 2A and 2B, and then come check your answer. Okay. This is what you should have gotten for 2A. If an angle is formed by perpendicular lines, then it is a right angle. For 2B, if an animal is a cheetah, then it has non-retractile claws. Okay. So that is our if-then form. Okay. The next part is going to be truth values of conditionals. I'm just going to use the book so that way I don't have to write it all out along with its explanation. Okay, so example 3 asks us to determine the truth value of the following statement for each set of conditions. Okay, so this is the statement. Okay, if you get 100% on your test, then your teacher will give you an A. Okay, so A here says you get 100%, your teacher gives you an A. The hypothesis is true, right? You meet this part. This is the hypothesis, right? This is the conclusion. The hypothesis is true since you got 100%. And the conclusion is true, right? Because the teacher gave you an A. Since what the teacher promised is true, the conditional statement is true. Right? Okay. Here, this one, it says you get 100%. Your teacher gives you a B. Right? The hypothesis is true, right? That you got the 100%. However, the conclusion part of your teacher giving you an A is false because the result is not what was promised. The conditional statement is false, right? Because this isn't what happened. You got the 100%, but you still got a B instead of an A. Okay. C is here. You get 98%. Your teacher gives you an A. Okay. The hypothesis is false because you didn't get the 100%. You got a 98%. However, the conclusion is true, right? Because the conclusion matches. Your teacher gives you an A. Okay. The statement doesn't say what happens if you don't get 100% on the test. You could still get an A, but it's also possible that you get a B. And so in this case, we can't really say that the statement is false. And so the statement ends up being true. And then, so now you're going to work on check your progress 3. You get 85% and your teacher gives you a B. Okay. So here, the hypothesis is false, right? Because the you get 85% doesn't match the if you get 100% on your test. But similar to part C, we can't say that the statement is false because we don't have that information there. All we know is that if you get 100%, your teacher should give you an A. So therefore, the conditional is true. Okay. So that's a little bit confusing, but what it shows us is that the resulting truth values in example 3 can be used to create a truth table for our conditional statements. Notice that a conditional statement is true in all of these cases, except where both the hypothesis is true, but the conclusion is false. Okay, right? So if P and Q are true, then the whole thing is true. Okay, even if the P is false, it's still going to be true. The only time when the whole statement is false is if the hypothesis is true, the conclusion is false. That's the only time. Okay, so now this takes us to example 4. Okay, we have a conditional here, and then we're going to write the converse, the inverse, and the contrapositive of the following statement. And we talked about that in the beginning of the video. Okay. After that, we're going to determine whether each statement is true or false. If it is false, we're going to give a counterexample. Okay. So the conditional here, it didn't have it. So we're going to start by writing the conditional. Actually, I'm going to write them all, and then I'm going to show it to you. Okay, so here you go. I first rewrote this as a conditional, right? So the statement was linear pairs of angles are supplementary. So my conditional is that if two angles form a linear pair, then they are supplementary. Then they are supplementary. That is true. Linear pairs are supplementary. Okay. The converse will flip them. So what happens is this part was here, and this part is here. And now what happens is they switched orders. Right? Right? So the converse is if two angles are supplementary, then they form a linear pair. Right? This is false. Okay. And here is my counter example. These two angles are supplementary, right? 70 plus 110, they add up to 180. However, they are not considered a linear pair. They don't form a linear pair. They're not even adjacent to each other. Okay. Okay. The inverse of them keeps the order of the original, right? So pink here, blue here. Okay, the difference though is this is the not, right? So the inverse keeps that order of the conditional, but now puts a not in front of both of them, right? So the inverse, if two angles do not form a linear pair, then they are not supplementary. And that is false as well. These two angles are not a linear pair. However, they are supplementary. Okay, so that's a counterexample to this statement here. Okay. And then the last is contrapositive. So contrapositive switches the order of the original, okay, and has the not as part of it. Okay. So the contrapositive says if two angles are not supplementary, then they do not form a linear pair. That is true. Okay. Okay. So you're going to do check your progress 4. You're going to do the same thing, but for the statement vertical angles are congruent. And then once you're done, come and check your answer. Okay, you should have gotten something along these lines. So I rewrote the vertical angles are congruent into a conditional. If a pair of angles are vertical angles, then they are congruent, and that is true. Okay? The converse just flips the hypothesis and the conclusion. Okay, so you see that my pink and blue got switched. It says if a pair of angles are congruent, then they are vertical angles, and that is false. And here's my counterexample. I have two 90-degree angles here. They are congruent, however, they are not considered vertical angles. Okay? The inverse leaves the hypothesis and conditional of the hypothesis and the conclusion of the original where they are, it just adds a not and negates both parts of it. So the inverse would be if a pair of angles are not vertical angles, then they are not congruent. Okay? So whereas the hypothesis is true here, right? These angles are not vertical angles. However, the conclusion was false because they actually are congruent in my counterexample. So the inverse is false. The contrapositive flips the hypothesis and the conclusion and negates both parts. And so the contrapositive of this would be if a pair of angles are not congruent, then they are not vertical angles, and that is true. Okay. That's it for today. Have a great rest of the day. Bye, guys.